Hi, and welcome to video 3 of 3 videos for section 3.2 for Math 181. In this video, all we're going to do is exercises, examples. So hopefully, if you have homework that you're doing, you can reference some of these problems. If you're going back and reviewing for an exam and you want to relearn something, hopefully these will be of use for you guys. First one we're going to look at is number 21. And that says the following: find the inverse of f of x is equal to 1 plus the square root of 2 plus 3x. So if you want to hit pause, if you want to try this on your own, if you get stuck, hit play again, that's fine. If you didn't really recall the process of what we do and you want to follow it through on here, that's fine, and then maybe practice some more on your own. So the first thing we're going to do is step 1 is write y equals this guy, 1 plus square root 2 plus 3x. And then in video 1, I believe it was, I told you this is where I do it a little different than maybe somebody else does it, or maybe it was taught to you. So in this case, I'm now going to solve for x. I want to get x by itself. I know some people teach it where now I'm going to switch my x's and y's and solve for y. Either way, it's okay. You're going to get the same value at the end. So if I want to get 3x by itself, the first thing I need to do is minus 1 from both sides. So when I do that, I'm left with 2 plus 3x on the right side, y minus 1 on the right, on the left. Now I got to get rid of this square root. I'm going to square both sides here. So I'm just going to leave this, y minus 1 squared, I don't have to expand it, is equal to, well, the square gets rid of the square root, so I have 2 plus 3x. Now I need to subtract 2 from both sides, so I get y minus 1 squared minus 2 is equal to 3x. I'm almost there. I just need to now divide by 3. So that tells me x is equal to y minus 1 squared minus 2 divided by 3. So now that I've solved for x, I just switch my x's and y's. So that means y, which in this case is actually my inverse function, so f inverse of x is equal to x minus 1 squared. I got to change those x's and y's. Minus 2 all over 3. So it's that 3-step process, right? Y is equal to the function, solve for x, then switch my x's and y's, and that gives me what the inverse function is. All right, next example is number 35. Again, these are in the book, so if you want to, reference a book, go to there, see what it is, write it down from there, that's fine. But we want to find f inverse prime of a for the function f of x is equal to 2x to the third plus 3x squared plus 7x plus 4 when a is equal to 4. So this was that piece at the end of video 1, theorem 7 I believe it is. It was labeled. So it's that kind of messy formula, and if this doesn't equal 0, it's 1 over this whole thing. So we have what? So if a is 4, what we're trying to find here, f inverse prime of 4 is just equal to, by theorem 7, 1 over f prime of f inverse of 4. So f inverse of 4. So I don't necessarily, and it would be extremely difficult to try to find the inverse function here. But let's say that, I have, so kind of taking a side trip here, f of x is equal to x to the third. So f of 1 is what? Well, it's 1. F of 2 is what? 2 to the third power is 8. F of 3 is what? 3 to the third power, 27, and so forth. So that's the function value. So that means what? Well, that means that f inverse of 1, this one, is equal to what? The value that got me there, 1. So that one's maybe a little confusing. I shouldn't have chose that value. But it also means what? F inverse of 8. So if I had the inverse function and I plugged in 8, what's it going to get me? It's going to get me 2. And F inverse of 27 is what? It's 3. So if I want, so hopefully that makes sense. If I have the function, I plug in some value, whatever function that kicks out, that's the same as the inverse function at that value there. So this one here, f inverse of 4, just says to me what value do I have to plug into the original function, f of x, in order to get 4 as my final answer. And hopefully you can see it that f of 0 is what? F of 0 is 0 plus 0 plus 0 plus 4. So f of 0 is 4, which means f inverse of 4, this guy, is actually equal to 0. So we didn't have to actually figure out the inverse function and so forth. The process was just figuring out, okay, what value would I have to plug into x in the original function in order to get 4 so that I can plug it in here. So f prime of 4, when a is 4, this guy, is equal to 1 over f prime of what? Of f inverse of 4. And we just figured out f inverse of 4 is 0. Now that doesn't mean the denominator is 0. It means what? It means we have to plug in 0 into the derivative of our f function. So if I figure out f prime of x, that's what? It's 6x squared plus 6x plus 7 plus 0. Derivative of a constant is 0. So if I want f prime of 0, so f prime of 0 is what? 0 plus 0 plus 7, which is 7. So if I want to find f inverse prime of a, when a is 4, that means it's just this guy here, 1 over f prime of 0, which is 7. So my answer is 1/7. So I'll be honest with you, I don't suspect you'll be doing a lot of these problems this semester. But that's how we get there. If you got this really messy looking problem, more often than not, it's a little bit more straightforward than it seems, because they're going to give you numbers that should work out nicely. So they picked a as 4 because when we plug in 0, all we're left with is 4. So we know that that value is 0. Plug 0 into the derivative just gives you 7. So that's our value in the denominator, and then you're done. So that's the end of that exercise, example number 35. Next example we're going to do, next exercise, is number 52. And this is utilizing our law of logs. So we want to express as a single log function. So remember when I gave you those law of logs, I said they can go either way. You can either go from where they're multiplied together and expand it to the plus, or you could take it if two are added together and combine them by multiplying. So the value The problem here is we have the natural log. It doesn't matter, log, natural log, the rules all apply the same. So natural log of a plus b plus natural log of a minus b minus 2 times the natural log of c. So you can do this in either order, which pieces you want to combine and so forth, but if I do these first two, I have two log functions that are being added together, so it means what? It means I can multiply the pieces after the log function. So this is the same as the natural log of a plus b times a minus b. So I have what here? I have a difference of squares, right? So minus 2 natural log of c. So if I simplify this, if I multiply these guys out, because it's a difference of squares, this is a squared plus b squared. And then minus. So in this case, I'm going to apply law number 3 of the law of logs, which means what? This number in front can really be taken as the exponent on this guy. So this is really like minus the natural log of c squared. I take the 2, I put it as an exponent on the c. And now because I have minus, this is law of logs number 2, where I can divide both of these pieces. So this is what? Natural log of a squared plus b squared all over this guy here, c squared. It's actually natural log of this whole thing. Whoops, this is wrong here. It's a difference of squares, so it's a squared minus b squared, a squared minus b squared. Sorry about that. So difference of squares, if you FOIL this thing out, you're going to get a squared, outside, inside cancel each other, and then minus b squared. Difference of squares, like I said. So why I put plus, not sure, but this should be a minus sign in here. So our final answer, taking this whole big mess, we can convert it to one single log function, which is natural log of a squared minus b squared all over c squared. All right, next example we're going to do is number 63, and we're just going to do part A. We want to solve for x, given the equation e to the 7 minus 4x power is equal to 6. So if I want to get the value of x, if that's what I'm trying to solve for, I need to bring this out of the exponent. I need to get rid of this e. And how do I do that? Well, I can take the natural log of both sides, right? Because remember, if I have the natural log of e to some exponent, this whole thing simplifies just into whatever the exponent piece is. 7 minus 4x is equal to the natural log of 6. So subtract 7 from both sides. So you get minus 4x is natural log of 6 minus 7. And to get x by itself, divide both sides by negative 4. So that gives you x is approximately, because you'll have to do this on your calculator. So plug in 6, hit the natural log button, then subtract 7, hit equals, and then divide it by negative 4. This should give you roughly 1.302. So the key here, applying the natural log function, and important, you have to apply it to both sides. You can't just apply, it's kind of like if you take the square root of one side of an equation, you have to take the square root of the other side of the equation. Same thing here. If I do natural log of the left side, I need to do natural log of the right side. So that's 63A. The last example, the last part of video 3 here, number 71. We want to find the limit as x goes to 3 from the right side of the natural log of x squared minus 9. So if I was to plug this in here, 3 from the right side, so that means what? So let's start with the bigger number, 4. So 4 squared is 16 minus 9 is 7. Then if I go 3.5, then 3.1, 3.01, 3.000001, minus 9. As soon as I get really, really close to 3 from the right side, this number is going to be just ever so slightly bigger than 9, but it's almost what? It's almost 0, right? So I'm really trying to find the natural log of this guy is really just the natural log of 0 from the right side. This thing's going to get closer and closer to 0. It'll never hit 0 because we're never actually going to 3. So it's always going to be a really small positive number. And so now remember, what does our log, or what does our natural log graph look like? It looks like this. So the limit of natural log of 0 from the right side is what? It's negative infinity. So the answer for the original, the limit as x goes to 3 from the right side of the natural log of x squared minus 9 is the same as the natural log of 0 from the right side, which becomes negative infinity. So that's it. First 2 videos, kind of refreshing your memory, hopefully, on a lot of stuff with the results, with regards to logs and inverse functions. Third video here, a bunch of examples, hopefully a good enough sampling, applying what we learned in video 1 and 2. Come on back and we will take on section 3.3.